Welcome to The Explainer. Today, we are jumping right into a fascinating logistical puzzle. Imagine this. You're starting on a single train, and you've got just 48 hours. How many different train journeys can you possibly connect together? It's a massive challenge of timing, connections, and, a really good strategy.
So here it is, the challenge itself. You're on one train. The clock is ticking. You've got exactly 2 days. The question is, how many other trains can you manage to hop onto? We're not just going to guess here. We're going to solve this thing with a clear step-by-step method.
Okay, so our journey starts right here, on train 12269, and it's leaving on a Monday. From this one single train, we have a 48-hour window to branch out and see just how far the rails can take us.
But, with a puzzle this big, you can't just wander around aimlessly. That's a recipe for getting lost. We need a system. We need rules. So here's our game plan, and it's pretty simple. One starting train, a 48-hour time limit. At every single stop, we have to explore all of our options. But that last rule, Rule 4, that's the absolute game changer. Once we've been on a train, we mark it and its return trip as seen. This is what's going to keep us from just going back and forth between two stations forever.
All right, let's do this. The clock starts now. We're officially on board train 12-2069. Let's see where this first thread leads.
First things first, we set up what we're calling a scene table. You can think of it as our journey's memory. We log our current train, 1226, and we also log its reverse pair. Boom, they're now seen. We won't ride them again. This simple little table is going to keep us from ever getting lost or going in circles.
Okay, our first chance to make a move comes at a big junction, Vijaywada. We get there on Monday, so the clock is definitely still ticking. We hop off, we look around. What's next? What's our connection?
And this is exactly where the real work kicks in. My goodness, you have to track this stuff carefully. We're checking every single schedule, every arrival, every departure. If you make one little mistake, you could miss an entire branch of possibilities. This isn't about luck, it's about being super methodical.
So from Vijayawada, we find a connection, train 02246. We jump on that, we follow it to Bhuvaneshwar, and from there we hop onto another, 02202. And just like that, we've run out of time. Our 48-hour clock is up for this particular path. So this branch of the journey is officially done. We went as deep as we possibly could.
And as you can see, our scene table is getting bigger with every train we take. We've now completely, totally explored every single route that started from that first stop in Vijayawada. So, what now? Are we finished? Not even close.
No, we backtrack. This is the key. We rewind our journey all the way back to our original train, and we just keep going to its next major stop, Nagpur. And from here, oh man, a massive brand new web of connections just opens right up.
And this slide just illustrates our strategy perfectly. The path from Vijayawada, it was deep, but it was pretty narrow. Now, this new path from Nagpur, it's sprawling. It's branching out through huge hubs like Mumbai and Delhi. But the rule is always, always the same. You fully explore one branch to its absolute end, then you backtrack and you start on the next one.
So we keep doing this. We repeat this process for every single stop on our original train, all the way to its final station. After a full 48 hours of exploring, backtracking, and meticulously tracking everything, what's the final count?
After all that work, how many unique trains did we actually manage to connect with? 15. From just that one starting train, our systematic adventure let us ride a total of 15 different train lines.
Now, this wasn't a guess, right? It wasn't a random number. We found exactly 15 trains, our one starter plus 14 new connections, because we followed that strict go deep, then backtrack strategy. But this whole thing was never really just about trains. So what's the bigger picture? Why does this even matter?
Well, it matters because that method to our madness, it's not just some travel plan we cooked up. It is a real-world demonstration of a really powerful computer science algorithm that basically runs our digital world. That strategy we've been using, it actually has a name. It's called depth-first search, or DFS for short. Remember how we followed that Vijaywada path all the way to the end before we ever backtracked to try Nagpur? That's it. That's the whole idea. You go as deep as you can down one path first. You were literally watching a DFS algorithm in action.
And the way we did it was by using a cool technique called recursion. Just think about it for a second. Our main mission was find all the connections from this station. So when we got to a new station, what did we do? We launched that exact same mission all over again. A process that calls itself to solve smaller pieces of the same puzzle. Well, that's recursion.
And what about that final map we drew? That path we traced out? It's not the entire Indian rail network, of course, just the parts we could actually reach. And by making sure we didn't go in loops, we created this perfect little skeleton of connections. In computer science, that's called a spanning tree. It's an efficient map of our entire journey. This chart here shows our journey perfectly. You can see how the algorithm tackled the branches one by one. First, that small Vijayawada branch. Then it backtracked and took on the huge Nagpur branch. And then the rest. DFS explores each possibility completely before it ever moves on to the next one. And that really is the beauty of this whole thing. We've taken a problem that seems completely chaotic and almost impossible to solve, and by applying a simple, structured method, we found a clear path to the answer.
And this kind of logic, it is everywhere. It's how a search engine spider crawls the billions and billions of pages on the web, going deep down one link, then backtracking and trying the next. It's how an AI in a video game finds its way through maze. It's a fundamental tool for exploring any complex system.
So if there's one big idea to take away from all this, it's this. A simple, recursive strategy, just like the one we used, has the power to unravel even the most mind-bendingly complex networks out there. Which really just leaves us with one final thought. If a simple method like depth-first search can untangle a whole national railway system, what complex network in your world could it help you map out and understand?